Now that we have a higher level perspective and understanding of how a neural network works, we actually want to start implementing it. And so the first thing we need to do is to create those weight matrices and bias vectors. And the way we go about it is, well, in the beginning, we have no idea which neurons should trust which ones. So basically, we will want to create random bias vectors and random weight matrices. And that's why I will teach you a couple of APL primitives that we will use in this effort. So if you are familiar with the roll function, the reshape function, with the exponential and with the circle primitive, and if you also know how to define a Dfn, please go ahead and skip this video. If these words make no sense to you or you want to relearn these, then just bear with me. I will start by removing the test I made in the beginning, so let me go ahead, delete this file, and also erase the variable so that I have okay, so sorry, I got scared. This is awesome. So I deleted the file in here and automatically the string variable was deleted because of the link I created. So if I type in string and press enter, it tells me it doesn't know what this variable is. So that's exactly what we want. All right, and so first things first, how do you generate random numbers in APL? It's pretty simple. If you type in the question mark, which is something you should already be able to type with your standard keyboard, and you type, let's say 10, and you press enter, then you generate a random integer. If you go ahead and press enter again, you generate a different random integer. And so the question mark is the primitive we will want to use. It's called roll, as in roll the dice. And you can think of it, you can recall, a mnemonic to know that the way to generate random numbers with the question mark is that it's kind of like a question. So what number will show up below 10? Okay, what number will show up below 6? And so that's how you can recall that the question mark is used for the roll function. But we want our levels of confidence to be modeled not by integers like this. We want them to be modeled by smaller fractional numbers, smaller decimal numbers, smaller floats. And that has to do with the mathematics that will later be used. And trust me that it makes a lot of sense to use smaller numbers, and it is going to make the numerical methods behave more properly. And that is basically why we use small numbers. And so if you want a random number between 0 and 1, you just type question mark 0, and it rolls a random number between 0 and 1. If you do it again, a new random number is generated. Throughout the series, if you want to, say, reevaluate something already typed, or you want to modify something already typed, if you press Control Shift Backspace, you can cycle through the things you typed in a backwards fashion, and if you hit Control Shift Enter, you can cycle forwards. So in here it's harder to see because I typed the same thing a bunch of times, but let's say, let's roll 2, let's roll 3, let's roll 4. Now Control Shift Backspace allows me to cycle through these, and Control Shift Enter allows me to move forward. And we will use this shortcut a lot because I'm lazy, and so should you be. Okay, so this allows us to generate random numbers, but we want to generate matrices and vectors of random numbers, not just a single number. And the way you do that is by first generating an array And the array is the generic term for all matrices, all vectors, and all things that have higher dimensions. So we are going to generate an array with the shape we want, and then we use the roll function. For example, if you roll 0, 0, 0, you will get 3 random numbers. If you roll 0, 0, 0, 0, you get 4 random numbers. But this is still a lot of work. What if I want 100 random numbers? Do I have to type 100 zeros? Well, that would be ridiculous, and that's not what you do. For that, you're going to use the reshape primitive that you can type with APL R. So this allows us to give some data on the right and give a shape on the left. And what we are going to do is, let's reshape this data with the shape on the left. And this basically creates 100 zeros. So now I can roll 100 zeros to get 100 random numbers. And you can see here I have all the random numbers over here. Okay. Your output might have wrapped to the next lines, and so what you can do is type closing brackets rows on. It can be lowercase, it doesn't matter, rows on, so that longer outputs can go to the right instead of flooding your session vertically. And also, maybe this was strange, or maybe you just dealt with it casually. Notice how I'm rolling 4 zeros. But if this was a standard programming language, maybe what would have happened was first I would roll the 4 to generate a random integer, and then I would reshape it with a 0. But APL is executed from right to left, okay, in a generalization of standard mathematical notation, and actually as an attempt to improve it. And so the only precedence rule you need to know when using these primitives, these primitive functions and values, is that things execute from right to left. And so the first thing that happens is these are turned into 4 zeros, and then we roll them. And also notice that the roll function automatically mapped over the 4 zeros. I didn't have to tell it to map, I didn't have to do anything special. It just worked. And this is because the roll function is a scalar function. And scalar functions will look into their arguments and make their best efforts to penetrate through the structure until they find the smaller irreducible elements, in this case the zeros. And so this generates random vectors. What about the matrix? Well, if you want to create a matrix, you need to tell it the number of rows and the number of columns you want it to have. This is a matrix of 3 rows and 4 columns, so I can roll that matrix, and then I get a matrix of 3 rows and 4 columns of random numbers. So this is it. Now I have this awesome functionality. I know how to generate a matrix of random numbers. So let's create a function to do this, because having to type the question mark and then the shape of the matrix and then reshape 0, this is a lot of trouble. So let's create a function to do this. Let's call it random array. And then what I want is this random array, I want to define it, I want to assign it a function. And in APL, assignment is not done with the equal sign, it's done with this left arrow that you can type with APL opening brackets. It's the first glyph in your language bar. And now for smaller functions and for simpler functions, it makes sense to define this as a dfn, which is short for dynamic function, and those are defined with curly braces. And so whatever I type in here is going to be the body of my dfn. And Dfns can get an argument on the left and an argument on the right, much like Reshape here got a 0 on the right and a 4 on the left, and much like roll, the question mark here, got this whole vector on the right. And for Dfns, the right argument is represented by an omega. You don't get to pick its name; it's always omega, and you can type it with APL W. And so let's say this omega is the shape of the random array we want. So you can see here, first we use the shape with 0, so let's omega reshape 0, and then we roll this. Now if you press enter, and you type in, say, random array 3, 4, you should get a random matrix. Be sure you get that, and make sure you type this correctly. And finally, in order to be able to create the random weight matrices and bias vectors like we want them to be, we just need to go over two other primitives, and those are the primitives for the exponential function and for some trigonometric functions. And we will take care of those in the next video.